Hello everyone, I am Asna, Assistant Professor, Department of Computer Science. Today we will be discussing one of the important concepts in operating system, which is deadlock. First we will be explaining the definition, later we will be moving on to the real-time examples, so it might be very easy for you to understand the concept. Moving on to the definition, if two or more processes are waiting on happening of some event but that event does not happen, this condition or this scenario will be called as deadlock. Moving on to the real-time examples, the first pictorial representation is representing a bank employee is there and a customer is there. Bank employee is saying that you have to pay 1000 rupees before creating the account, but the employee is not willing for that. So here the bank account creation process is not happening. So this scenario, both are not willing for a compromise. So this scenario or this condition will be considered as a deadlock in real-time examples. Moving on to the next example, as you can see that two cars are there, car 1, car 2. Both are not willing to take their car reverse. So in the situation also both are not ready for a compromise. This condition or this scenario will be called as deadlock. So hope you got the concept. Two or more processes are waiting of happening of some events, but that event is not happening. This condition is actually called as deadlock. Next we will be discussing what is deadlock in operating system. Actually, every process needs some resources in order to get executed. Consider this P as a process and this R as a resources. Process P will be requesting for the resources in order to get executed. So if the resource is available, then the operating system will grant those resources to that process so that process can get executed. What if the resources are already allocated to some another process? Then this process have to wait until this process releases those resources. Then only this process will get executed. So hope you got the concept. This is what we meant by deadlock in operating system. So a deadlock is a situation where a process is already holding a resources and which needs some another resources as well in order to get executed, but those resources might be held by some another processes. Okay, so here the both processes executions will not happen. So the scenario or this condition is called as deadlock. Let us assume that there are three processes and three resources. This P is indicating process and R is indicating resources. In this pictorial representation itself, it's clear that process P1 will get executed if it is getting resource R1 and resource R2. The process P2 will get executed if it is getting resource R2 and resource R3. The process P3 will get executed if it is getting resource R3 as well as resource R1. Okay, so each process will get executed if it is getting two resources as well. In this pictorial representation, it's clear that process P1 is already holding resource R1 and which is requesting for resource R2. But resource R2 is already allocated to process P2. So the process P1 is not going to get the resource R2. So the process 1 is actually stuck. And what about process 2? Process 2 is already holding resource R2 and which is requesting for resource R3. But the resource R3 is already allocated for P3. So the process 2 is also stuck because resource 3 is already allocated to process 3. So the process 2 is not going to get the resource 3. What about the process 3? Process 3 is already holding the resource R3 and which is requesting for the resource R1. The resource R1 is not free, which is already allocated to P1. As you can see, these three processes are not going to execute. So this condition or this scenario will be called as deadlock. We already went through the example of deadlock, which is very easy, that the process P1, P2 and P3 is already holding a resource and which is requesting for another resources in order to get executed. So the process P1, P2 and P3 is stuck currently, which is not going to execute. It is requesting the resources in a circular manner in this pictorial representation. So this we can call as circular wheel. Okay, so we'll be moving on to the next slide. Here you can see a simple explanation or an example of deadlock. There are two processes, process P1 and process P2. The process P1 need resource R1 and resource R2 in order to get executed. What about process 2? The process 2 need resource R2 and resource R1 in order to get executed. So what is the condition over here? you can see process P1 is already holding the resource R1 and which is requesting for resource R2. What about resource R2? Resource R2 is already reserved, right? Because the resource R2 is allocated to process P2 and which is requesting for resource R1. What about resource R1? Resource R1 is already holding by process P1. So this scenario, so we can conclude that the process P1 and process P2 is not going to execute. This is actually what happens in deadlock. Hope you got the concept. Next we'll be discussing 4 necessary conditions of deadlock. The first one is mutual exclusion, second one no preemption, third one hold and wait, and the fourth one circular wait. The first one is mutual exclusion, which means only one resource can be utilized by a process at a time. A resource is not shareable by multiple processes. Okay, so the next one is no preemption. The process is holding at least one resources and waiting for the another resources in order to get executed. Sometimes it might happen that a process need multiple resources in order to get executed. Okay, so the third one is hold and wait. A resource cannot be taken from the process unless the process releases the resources. What if the resources which we are requesting, which is already engaged in some another process, and after those executions the operating system will be releasing those resources, so at that time you can utilize those resources. And the fourth one is circular wait. In the previous slide also we explained that it's happening in a circular manner, so this is the best example for circular wait, which means the process requesting is in a circular manner. Okay, so this is the example of circular wait. Hope you got the concept. So all these pictorial representations are mentioning circular wait itself can be in multiple manner. So that's all for today. Hope you got the concept. Thank you.